We are very excited to welcome Kief Morris, Principal Cloud Technologies at ThoughtWorks. A big round of applause, please.
Thank you very much. Thank you. It's a real pleasure to be here. Just a little bit about myself. I've been working in IT for, I guess, more than 25 years now. I worked across kind of software development and systems administration, and I was always very interested in how to use automation to build and configure servers and environments and this kind of thing. I joined ThoughtWorks about 12 years ago in London, although I'm originally from the US. I was living in London then. And at that time, things like DevOps and cloud and infrastructure as code were all very new. These were words that had come up in those few years since 2008 or so. I think most of those things started to emerge. And the thing that interested me about ThoughtWorks was a book was coming out called Continuous Delivery, which really put together a lot of these concepts, and I found it very interesting. And I was also very interested in how ThoughtWorks had been so instrumental in introducing corporate enterprises and the business world, and also nonprofit and public organizations to things like agile, test-driven development, extreme programming, all of these kind of really fresh ways of working and building software and delivering software. And so it was really interesting to me that they were now moving into areas that I felt I had a particular kind of background and passion for. So I joined ThoughtWorks in 2010, and back then I was just somebody who was interested in these technologies, and I worked on projects with clients along with teams to do things like create pipelines for automatically deploying software into different environments, talking with client organizations about things like how to use these technologies in a really useful way. And after a few years of doing this, I was inspired by those conversations I've been having with clients and also with other thought workers that I worked with who did things like wrote books and spoke at conferences and did these kind of things, to think that I can try this myself. And so that's how I ended up writing the book Infrastructure as Code. And just a year or two ago, I wrote the second edition of that book. That's been my journey kind of in the industry and ThoughtWorks, and it's brought me here, which is great.
Yeah, very nice. Thank you, Kev. Well, the dynamic of this session will be, we're going to do some interview type questions, right? But for the people, feel free to raise your hand, and some of the staff will give you a microphone if you want to give some question from Kev. Okay? So Kev, I guess that this question is very common these days for you. Ecuador, about Ecuador. How Ecuador has been treating you these days? Have you had a chance to visit any interesting place?
So far, I've mostly been in the office and doing these kind of things. In the evenings, I've been going to some nice restaurants. The food has been fantastic. My family's here with me, and they've been, while I'm working, they're out touring around and doing interesting things, seeing the center of the world and all those kind of cool things. This weekend, I should have the chance to see it a bit more and relax a bit more. But so far, even just looking around out the windows has been pretty impressive.
Yeah. Yeah, that's right. And what about the food? Do you have the chance to try some?
Yeah. So having the ceviche and the empanadas and the nice kinds of seafood and everything. It's been great. I could go on and on.
Yeah, very nice.
It is great to listen this. Do you have awesome days? I think. Do you visit different places and know different amazing diversity in Ecuador? Yes. We are very interested in knowing more about your life or your experience. But so in your experience, what would you say are the main challenge you have faced in managing the technical product or solution over the infrastructure?
Okay. So the interesting thing I think about working with kind of clients that we work with and helping them with these technologies is that it's often not the technology that's the issue, and this is true obviously not just for the infrastructure, but for just regular software and other things like machine learning and data. The trick is really, it's not enough just to say, put software onto a cloud platform or to adopt tools to automate. You really have to think about what's the best ways to do this. So for instance, in software, one of the things we've always done a lot of is we help organizations who have built these complex software systems, and they've become very messy, and so they need kind of modernization, refactoring, restructuring. So that's where the idea of microservices came from, was work that we did with organizations that had very monolithic and difficult to change software, and we found kind of better patterns for breaking it into smaller pieces. And so with infrastructure and cloud, I think it's a very similar thing. We're seeing, in the early days, it was helping organizations start using cloud and start using infrastructure automation tools. And these days, we're now getting involved with organizations which have been using these and need help to kind of help them to scale or become more stable. And again, so I think the thing with infrastructure in particular that's been challenging is, or maybe useful, I guess, in thinking about these challenges, is looking at things that we learned from software development and software design, things like microservices, things like object-oriented design principles, and how to bring these into infrastructure. Also things, especially agile engineering techniques like test-driven development and so on. So it's been, how do we bring those into infrastructure, I think has been helpful with those kind of challenges.
Yeah, well, about this post-pandemic situation, right? You have seen like an increasing thing with the industry of technology and even here with the infrastructure field.
Yep. Oh, definitely. Definitely. So some of the things we saw, so I work with clients largely in the United Kingdom, but also I work with teams in some of our other locations like Australia and so on. And one of the things very early on that was a lot of the retailers, so the stores who maybe had an online e-commerce site, but it wasn't ready to handle when everybody was at home and started ordering things to be delivered at home, the websites, even though they were hosting on the cloud, they weren't ready to handle the number of users. So you would see they would be putting up pages saying you have to wait in a queue before you're able to shop and put things into a basket and order. So that was really eye-opening, I think, to seeing like how much more people needed to do to really get the most out of cloud and to help them scale in those kind of situations.
Yeah, absolutely.
Sure, it's great to know. But in this context, what do you think are the biggest challenges over the work challenge between the different kind of teams, such as developer or infrastructure teams or other teams in this context?
Yeah. So I mean, I think we've always had challenges with people being too separated and too focused on different goals. So you have developers who are asked, we need you to write new features and ship code. You have infrastructure people and other people who are asked to make sure that the systems are running stable and staying online and being secure. And so I think one of the challenges always is how to get people to work together towards common goals and have common things that they're trying to do so that these things will work together more nicely, which was the original idea of DevOps. I think these days where so much work is kind of distributed and people working remotely, it can be even harder because you only tend to talk to people when you have a specific thing. We have a meeting, so we'll talk. So you don't see people in the office, as much to say, oh, let's talk about this thing. Oh, as long as I'm seeing you, I remember, we have something interesting to talk about, problems that we can help each other with.
Yeah, working remotely it can be some challenging, I guess. Well, in infrastructure, we have some sensible default practice. Can we talk about this? What is the sensible default practices?
Sure. So in ThoughtWorks in particular, we've come across our different kind of areas of craft. So it also includes QA, software development, project management. Each of these kind of communities has come up with sensible default practices, what we're calling that. In infrastructure, we have those. And the idea of these is what are things that we believe, our opinions on what is really helpful, and especially things that maybe aren't things that everybody do in the industry. So for software development, we talk about things like pair programming, we talk about continuous integration and trunk-based development as things which we think are especially effective. For infrastructure, it really builds on the software engineering. So it is things like, okay, we think we should be doing things like test-driven development for our infrastructure code. We should be using things like continuous delivery pipelines so that we make a change to infrastructure code and it can be deployed to one environment and tested and then moved to the next environment and copied to the next environment so that each environment is consistent, that it works in the same way. So that's another practice. And it's also about treating all code as first class. So you'll find sometimes that people will, maybe teams will be very good with their software code, their Java code. They use very good practices and design and code reviews. But for scripts that they use for things like deployment or configuration, they don't really pay as much attention to it and treat it in the same way. And this often means that those things go wrong, and so we have failures of deployment because the script doesn't work quite right. And so another one of our sensible default practices is all code, infrastructure code, configuration code, testing code, we need to treat it all with the same kind of, respect and quality that we do for our software code.
Yeah, and these practices, I guess, that's really connected with the DevOps culture and with the site reliability engineering, right?
Very much, very much. So one of our kind of core beliefs is has always been with the agile ideas that developers should work closely with customers to understand their requirements and have very close communication and collaboration. That was kind of the original idea of agile software development. And with DevOps, the idea is, well, also we should think about the people who do support and the people who manage the servers and systems, and to make sure that they're very closely involved, and that rather than building software and then saying, okay, how can we deploy it now and how can we run it and make sure that it's stable, we say, how do we think about those concerns as we're developing from the very first line of code, that we're doing this properly, we're doing security from the beginning and all of those kind of things. And then SRE is taking a kind of fresh approach to thinking about how do we keep our systems reliable, how do we run things with a high level of operational quality. And as with DevOps and even Agile and other ways of thinking and working, different people use them in different ways, and I think it's very important they often tend to fall into becoming silos again, and so you have a separate DevOps team, you have a separate team to do this. And one of the pitfalls that we see sometimes with SRE is where it's a separate team now that worries about support or keeping the systems running, and so other people don't worry about that. And that means you have a disconnect. And so people are building software who don't necessarily know whether it works very well. And people are then, in another team, are trying to keep it working without being able to change and improve the quality of the software at the beginning. And so I think it's important with these kind of things, with DevOps and with SRE, not to see them as a separate function, but as something that the whole team has to do and has to take collective and collaborative ownership of.
Yeah, sure. I really.
I agree with that. In this context, what factors are important to guarantee the security in one infrastructure project, or maybe around the teams?
Okay, so security is an interesting thing with infrastructure and cloud. It creates some new threats, some new things that you need to worry about. So, for instance, it centralizes things. So you have this with like a continuous integration, a continuous delivery server. Like if you have a Jenkins server and it manages all of your code and maybe it has all of your passwords, you now have to think about very carefully about how do we secure that. I know I attended a talk a few years ago from somebody who did security. They would do attacks on a company to help them to kind of find the weaknesses. And they said the first thing we always look for is a Jenkins server, because the Jenkins server will have the database passwords. When we have the database passwords, we get everything. And infrastructure as code can be a similar kind of vulnerability. If I can get to the infrastructure code, and especially if I can get to the things that run it, then I can control all of your systems. So you have to think about The same kind of, it's the same principles that we have for security and anything in the systems. We have to think about things like separation of responsibilities of systems. It's not just about people and saying that different roles are not allowed to do different things. It's saying, if I get access to this part of the system or this service, what can I do? What do I really need to do? Do I need to be able to do all of these things? Can we kind of then limit and control those things? On the flip side, infrastructure as code can give you some powerful tools for security because it enables you, in the old kind of ways of thinking about security, especially network security, you would have like a very large boundary, say a DMZ, or you have these kind of security areas, and it would be a very big area that would have a firewall protecting it, but once you get inside, you have everything in there. And that's because it was difficult to maintain these things because it was all done manually. But with infrastructure as code, you can write code that can be reused so that every aspect of your system can have its own little firewalls and protections and so on. And so this is where you get concepts like perimeterless security, where you're not focused so much on making a wall around everything, but making sure that everything inside the wall is very secure. And also things like having automated tests that run that test the security, that test that the access is not allowed and the right things are in place.
Cool. And in this context, or in your opinion, it's important to keep in mind aspects over the quality of the infrastructure projects, the infrastructure of code, or other things of quality of the project?
Yeah, I mean, quality is obviously very important. And it's one of those things, as with software code, where we really need to think about building the quality in from the beginning. And so this is where I really like working with QAs, with quality analysts as a part of the team. Again, moving away from the idea that a QA is somebody who, after you're done, they look at it and try to find problems. Actually, a QA should be part of the team, looking at as you're building it and saying, well, what about this? What about that? How do we know if it's working well? How can we write tests that work well? What should we be testing? I find that perspective is really helpful to have in the team, and so that from the beginning you're writing your code and building your infrastructure in a secure way, rather than trying to figure out how to change your code and change your systems after you've built it to make it secure.
Yeah, definitely. Well, I have a hard question for you.
Oh, good.
When we work with infrastructure projects, how we can define an MVP?
A minimum viable product for infrastructure. That's interesting because it can be quite difficult, right? Because when you look at what's necessary to run an application, even a simple application, it can be quite a lot. On the projects that I've been with and that I've worked with, what we typically try to do is think about this in conjunction with the application. So what is the first, as we start developing the application, what's the first thing, what are the first stories that the team is going to play? And so often we might do something like it's a hello world application. It has no data, it's very kind of simple and basic. And so then we can think about, okay, we don't need all of the infrastructure that we know we will need later. We don't need a database at first. We don't need maybe message bus or other things at first. We just need the ability to run a simple application. And so you can think about, then you do want to think about things like, so how do we build in the security for that simple application? Obviously, it's simpler to secure a very simple hello world application, right? So you build in just a little bit of security, just what you need for that. And then you build these habits of then, okay, we're going to play more stories for the application, and we can play more stories for the infrastructure that we need to support those. Another technique that we use for to kind of make sure we can do incremental development of infrastructure is we might use simpler versions, especially with cloud. We might use a simpler type of service at the beginning than what we're going to use later. So as an example, on one project I was on working at a bank in the UK a few years ago, we had in our mind, we wanted to use Prometheus for monitoring because it was a really powerful tool, and we wanted to use Vault for secrets management because that's also really powerful. But we also knew it would take several weeks to get, because we wanted to have automation for those services to deploy and build and configure those. And so that would take a long time to build that. So we started with using just AWS out-of-the-box services. So we used CloudWatch, even though it didn't have all the functionality that we wanted. And we used the SSM secure parameter store service. Again, we knew it wasn't going to support what we would need later on, but it was enough to start the team so we could have a minimum viable product, even of an application that could go into production, at least with a few users. And then we can build up, we made our backlog of epics to say, like, here's the point where we're really going to need the proper monitoring server. And so by then, this is the point when we need to implement Prometheus, for example.
Yeah, exactly. When we are working with these MVPs and we have a board full of backlog items, sometimes we find hard to prioritize these PBIs, right? How we can do it? Some keys to achieve that?
I think it's useful to think about the outcomes and goals that you have for, again, the high-level application or whatever it is that you're building the product. So you think about the kind of roadmap for implementing that. So oftentimes the first thing we're going to do is we're going to have a very simple version of the application that we're deploying that we can show to our stakeholders. We can do demos and showcases, but it's not going to have real users. It's not going to have real data. And so thinking about that as the goal helps you to decide, okay, what stories do we need to play now and what can we play later? Maybe we don't need to play stories that will help us to scale to a very large number because it's only going to be for a demo. So we can leave those stories for later. So again, thinking about the outcomes and what we're trying to do with the software that infrastructure supports helps us to kind of limit what we need to do right away.
Cool.
Thanks.
In different projects or infrastructure projects, do you have, you see different implementation of Agile or security principles that you share with us?
Security principles?
Or Agile project, or Agile principle, Agile, sure.
Agile principles, yeah.
Agile practice.
Yeah, okay. So, I mean, some of the techniques we use, one thing we like to do is threat modeling, where we have workshops to think about what are the different things that can go wrong security-wise. Who are different attackers, whether they might be, I don't know, foreign governments in some cases can be, things we need to worry about. It can be even like internal people. Maybe you have, you have to worry about what happens if somebody gets angry with the company and tries to do damage. And so thinking about those kind of situations helps you to think about, okay, what kind of things should we do to mitigate those? So a common example is with AWS. What happens if somebody gets a hold of our AWS keys, API keys? If it's not designed well, somebody can use that key to lock you out and take control of everything you have, take all of your data or what have you. And so you think about, okay, so what should happen then? And this is where you decide, okay, we're going to have maybe multiple accounts that are with different keys or different keys with less privileges or these kinds of things to limit the areas of so this is the limited responsibility. So going from that, thinking about what are the threats, what are the things that we would like to be able to do to reduce those, and then creating stories and epics for our backlogs to decide when to play those.
And other question, in your opinion, themes or topics over DevSecOps, or maybe DevOps, or maybe GitOps, for example, maybe themes, topics over trends over infrastructure, do you apply in different projects?
Yeah, so I guess one thing that might be interesting to talk about is the types of languages. So infrastructure code, and this is getting maybe a little bit more deeper technical than some of the other conversations we've been having, but most infrastructure as code languages tend to be declarative. So they say, here's a subnet, it's almost like configuration, here's a subnet, here are the characteristics of the subnet, and then the tool runs and makes that thing happen. There's a growing, I guess, trend of using tools like Pulumi and the CDK, AWS CDK Cloud Development Kit, which let you use kind of real programming languages like, say, Python or TypeScript or so on to write your infrastructure code. I think my view on this is that you need to think carefully about which type of language and which type of tool to apply to different situations. So I find that the old declarative types of tools and languages are less useful when you're trying to create, say, libraries and modules that you're going to reuse. these are the kind of examples where especially software developers look at infrastructure code and say, oh my, this is terrible, this is not how code should be, and it's because you're trying to say, pass in some parameters and then do different things depending on things, and so you're trying to create logic. An example is, so Ansible uses YAML, which is a declarative language, but you find people, but then it adds in things like you can make loops, and you can make conditional statements and so on, and so you end up with programming in YAML, and that's just wrong, right? On the flip side, so these kind of regular programming languages are good for writing libraries and things that you're going to reuse. On the flip side, they're too heavyweight for some of the more simple things. So you'll see sometimes where people are trying to write code in infrastructure which says, if the environment is dev, make the cluster this big. If it's staging, make it that big, and so on. And so you have a lot of code where really what you just want are configuration parameters, key values. Here's a list of the values for the dev environment, for the staging environment, for the production environment. And so those can be simple. And then you might have the more complicated code which reads those and decides what to do.
Yeah, interesting. Having all these components with less code, right?
Yeah.
Interesting, but one step more about chaos engineering.
Chaos
What do you
engineering.
What do you think about it?
Yeah,
Very interesting for resilience, right?
Yeah, it's useful. So chaos engineering is the idea of of injecting failure into your systems to prove how resilient they are, right? So if you have systems which should automatically recover, so let's say you have an auto-scaling group in Amazon, and if a server fails, it should create a new server to replace it, and these kinds of things. Or what happens if a region goes down in your cloud provider, that you have systems which will kick in and move traffic over to another region. And I think these things are useful because you want to prove that these things work, and that the more that you're exercising them, the more confident you are that they will work in reality. I think many teams and organizations find them a bit scary, especially to do in production. So this comes from Netflix, right? They kind of pioneered this concept, and they do it in production, right? And they use entire regions. I think they use Europe as a failover zone for North America. But I think that there's a couple of key things there. One is you can use these in pipelines. If you're using pipelines for your infrastructure code, you can say, to test that automatic recovery, we can create a very small environment, we can inject a failure, and then we can show that it does recover, and we can show that things like monitoring alerts do fire that should fire, and these kinds of things, and logging events do happen. So you can prove those things in a safe way. And then where you are doing these kind of things in production, I think it's important. Well, I guess it's important to realize that you're not doing these for random things. It's not just going in and crashing things crazily. We know we have implemented a function that will recover this thing, so let's just show that yes, it does work in a way that's not going to actually interfere with kind of live traffic and real transactions.
Yeah, and about the application of chaos engineering, what do you think about the teams that are going to apply? Teams need a level of mature, maybe projects need to be ready to test it, or we can start applying chaos engineering for the first time? I think
it comes as a part of your implementation of things. So chaos engineering is about availability and resilience. So it comes part of, okay, we're going to think about how to make our system more resilient, and especially it's about the automation of that. So how do we know, we want to implement something that will automatically recover from certain types of failures. So I kind of would view it in a way like test-driven development, where you say, I'm going to write a feature of my code, so while I'm writing the feature, I'll write the test that shows me, yes, I did implement the feature correctly, it does what I expect. And so I would kind of view it as like test-driven development for your resilience automation.
Yeah, for sure. Well, around infrastructure as code, this famous term now, right? What do you think is the future of this in terms of management policy, testing? What's the future of infrastructure as code?
I think where things are going there is right now, infrastructure as code tends to focus very much on the low level. So if you look at the kind of code we write in Terraform as a language is one of the most popular tools for doing infrastructure as code on cloud platforms. It's basically a wrapper around the very low level infrastructure primitives that the cloud platform gives you. So it's a subnet, it's a network route, it's a load balancer, and all these very kind of detailed things. And so Terraform lets you kind of wire these together. But what tends to happen is that people create essentially snowflakes as code. So they create an environment that is very kind of special and very complicated and is very difficult to change. Where I think we're going to be moving to, and also it makes it difficult for developers. So our ideal is that developers have control over their environments. You know, if I need an environment because I'm creating a new service or a new application, I really should be able to do that, you know, myself without having to ask somebody else and wait for them to put it on their queue. But it takes a lot of knowledge to be able to do it at that level. So what I think we're going to see is teams and organizations building these layers in between. So where the developers are doing is saying, my application needs a database with this much storage. It needs a connection from the public, so it needs an inbound, you know, web connection. Maybe it needs message queues and so on. But the things that are at the level that the developer, you know, needs to think about. And so I think that, and we see this at clients already where they're implementing this, but kind of everybody is doing their very own kind of custom implementations of scripts to say, I can make a YAML file for my application to define these things. And then something reads that YAML file and then runs infrastructure code at that lower level. So I think we'll see a kind of maturing of that level. And what you'll see is teams building these kind of reusable components that are exposed then to developers in a level that makes sense to them for their applications. And I think these teams will probably tend to use more of the languages like the tools like Pulumi and so on, where they're using more dynamic languages, object-oriented languages to build kind of libraries of code for that codifies how the organizations, you know, what their policies are and what our governance is and so on in our organization. They can kind of put that into code. And I think those teams will tend to combine development skills and systems administration skills, because I think we'll need both of those together in order to build that really effectively.
Yeah, definitely. Well, yeah. Before to end with our interview, we would like to have one final thought of you. Do you have a message for the people who is interested in infrastructure, what path to follow, if they need some resources? Obviously, your book.
Yeah. Okay, so aside from my book, which is available at Amazon and all fine, kind of, you know. So just as kind of a, you know, for those who aren't familiar, the book kind of covers high-level concepts of infrastructures as code. It's kind of like patterns and principles and practices and ways of thinking, as opposed to being, here's how to write specific code in specific languages, partly because things change so fast, it's hard to write a book telling you how to do Terraform on AWS because a month later something changes and it's different. So that was maybe me being a little bit lazy. But I think there are also concepts that apply across tools and across clouds and things that hopefully persist a bit longer. I recommend there's as a starting point, I guess, there are several email newsletters that I subscribe to. So one is Last Week in AWS, which Corey Quinn puts out every week, focused mainly on AWS. He also focuses on cloud economics, so cost management in the cloud. And so I also follow him on Twitter. He's a good resource. There's Devops Weekly, which Gareth Rushgrove puts out. He's been putting that out for ages, probably, I think as long as I've been at ThoughtWorks. When I joined ThoughtWorks, I think he was already doing it. And we actually worked with him on a client project in London as well. And so he puts out like links to things, and it's resources on things, different topics around infrastructure and cloud and so on. And then the third one I would say is called DevOps-ish by Chris Short. And again, all three of them kind of have their different angles and their different kind of things that they tend to focus on. But they just give you, like, every week you get more links than you can click on and read, but you can kind of like skim through and find interesting things and you can go through their kind of archives as well. So I'd recommend that as kind of a good entry point.
Thank you, Kief. Thank you for all your insights and your recommendations.
Thank you.